Okay, I just bought this Chinese micrometer and just tore it apart. Let's put it back together. Start by oiling the surfaces. When I first got it, it was grinding and creaking and all that. But now it's a lot smoother, cleaned off, got the chips off. There weren't really chips in there, it was just dirty. Somebody installed it in a rush. And as you can see, you can't put this locking screw anywhere you want because there's a groove here cut by some guy with an angle grinder, obviously. Let me double zero that. So it wasn't zeroed, it was a mess. And assuming this 5mm gauge is right, and we'll have to find out. Oh, we just missed it, just by a hair. Okay, so you have to, if you're buying a Chinese micrometer, yes, it's cheap. Yes, micrometer or whatever other great company will cost you a bunch more. And yeah, it's going to be worth it. Okay, this is definitely not the smooth action you can expect from a high-end one. And for crucial measurements, I'd say you'd want to buy a high-end one. So it took about half an hour. I cleaned it and it's set, working condition. It's ready for use. It's repetitive. I've tried it several times, zeroed it in. I could try it even another time. And let's see how it goes. And we're in 0. 5-0. So, if you're, let's put it this way, if you're purchasing it to find the OD of materials you're working with, and it fits your needs and financial status, it should work. Just bear in mind, you're going to have to clean it up, open it up, grease it up, oil it up in this case, and make sure it's in working condition before you can start working with it. It's not something that, just like my micrometer caliper, when I bought it from micrometer, it was ready to go because it was calibrated, quality control and all that. Let's do a field test. I've got this 15mm ID aluminum tubing, let's give it a shot. Let's see how it does. So I'm going to expand this, and it goes the other way around compared to a standard micrometer, which makes me always do it the wrong way. Okay, and I'm trying to rotate here. I've got some clicks here. So this is 14.94. Let's do another measurement. Let's see. Take the tube on another side. Same result. 14.9, almost 9.5, 4.5. Okay, that's cute. But how do we verify it? Well, let's take a bore gauge, compress it, and if you close this, it tightens. I'm going to release it, spring loaded, never unscrew it completely because then things will start flying. I'm going to try, and this is something I can show you, I'm going to try and get it in the middle more or less. Trying to rotate it slightly, making sure it's sitting perfectly, and then I'm going to lock it. Okay, try again, because I got loose because I was not holding it right, and there we go, and we've got it loose now. Okay, I'm measuring more or less on center. Feels good. And it says 14.99. Okay, let's try and read one last time. And now I'll repeat the step with the tube. 14.99. Okay, that's pretty darn good for a tube. That's supposed to be 15, and it's extruded. Okay, this looks nice and even. You can see it's running not at an angle, but exactly more or less the length, and you can feel it. You can feel where you're in off. You can try to rotate it and see if it's trying to move because it's not really centered. And I'm locking it, and I'm trying to be parallel to the main tube, main axis. Okay, let's remeasure, and we're going to try and hit both center points of this gauge, and there we go. That's a good contact, and you always want to measure more than once if you're crucial about that. Okay, so this is 14.97 this time. Let's try again. Making sure we're centered. Okay, this is good. Got a good contact there. And 14.98. Okay, I think we can conclude this as 14.98, and we, according to the place where we measure, we have plus minus 0.01 millimeters of difference. So let's retry this gauge and put the micrometer. And this is the stuff that makes me want to buy the expensive stuff. Me2U slash any other good company out there, not China. Now China does, you know, make good micrometers, I'm sure, because most of these companies are making good micrometers. But hey, and when they're making it cheap, they're making it very bad quality. So. Now it says 14.96. Okay, so 14.96, 14.98. I'd say that's close enough. 14.96. Let's try a 90-degree. Making sure exactly along the axis. Okay, let's get it out. And we are at 14.95. Okay, so the deviation between the two micrometers, and I do trust the Meter 201 by far better than I trust this one. Considering the fact that I had to calibrate it myself, and I'm not an expert calibrator. So this is pretty good. So doing the math, we have a 0.1333, etc., etc., percentage error compared to the Meter 201. Not a big issue. Definitely not a big issue. And this is going to be, well, easier to measure compared to this one. So I can use these gauges once I'm getting to the final point, and I'm going to use the micrometer and so on. But for the meantime, getting to the spec, I think it's going to be pretty good. So this is definitely usable. Now, if you're working with wood and you need our precision and measurement, this is not that bad. So this concludes a very long bonus chapter, which I didn't plan on doing it that long. Just sharing thoughts. Sorry for the length, and I'll be seeing you guys shortly. So thanks for watching. Have a sweet day.